Welcome to solverfy.
Okay, so we're doing chapter 22, problem 57 here. And it says a point charge Q is placed at a distance r0 over 2 above the surface of an imaginary spherical surface of radius r0. And this is what we have shown here in this drawing. So part A, what is the electric flux through the sphere? Well, electric flux is given as the charge enclosed through our Gaussian surface over epsilon naught. And we can see here there's obviously no charges enclosed, so this is 0. Part B, what range of values does E have at the surface of the sphere? So the maximum electric field will be at the point on the sphere closest to Q, which is obviously at the very top of the sphere. And we know the minimum will be at the point on the sphere farthest. So this has to be the max. So by E max, and this part's the absolute farthest away, so this is E min. And we know this because, excuse me, the electric field from a point charge is proportional to 1 over r squared. So it only depends on the distance, so that means the closest point is going to be the maximum and the farthest the minimum. So now let's calculate what these are. So let's do E max first. So this is just 1 over 4 pi epsilon naught times the charge over r close squared. So let's rewrite that out. And this is 1 over 4 pi epsilon naught q over r naught over 2 squared, because that's the distance it is, as we see here. And if we solve or simplify that, this becomes out to being q over, not 4, over pi epsilon naught r naught squared. Cool. Now let's find the minimum. It'll be the same equation here with r being the farthest. Now the farthest is going to be a half r naught plus another r naught plus one more r naught. So this is going to be 5 halves r naught squared. So if we square that out and simplify it, this is just 1 over 25 epsilon naught pi r naught squared times q. Cool. So that means the range of values in is just range from q over 25 pi epsilon naught r naught squared all the way to the max, which is q over pi epsilon naught r naught squared. Cool. So these are the range of E values along the sphere. Part C. This asks, is E perpendicular to the sphere at all points? So we know that E comes out radially. So the only places it can be perpendicular to the sphere are at the min and max points. So it's not. If we just look at how the E field comes out, exactly just the 2 points we've already discussed are the only points that's perpendicular. So not perp at all points. Cool. Part D. This asks, is Gauss's law useful for obtaining E at the surface of the sphere? Well, since the electric field is not perpendicular or constant over the surface, Gauss's law is not useful, because the only way Gauss's law is useful is if we can assume E field here is constant or perpendicular at over the entire surface. That way we can pull it out and just call this E dot A. But this is not useful in this case because we already said it's not perpendicular or constant at all of these points. So this is not useful